So, I mean, usually, right, when we talk about a major revolution in physics, we picture something uh, highly technical.
Oh, yeah. You immediately picture like a massive particle collider.
Exactly. Like some multi-billion-dollar machine buried under the Swiss Alps, just smashing atoms together.
Right. Or, a giant space telescope peering into the absolute edge of the observable universe.
Yeah, we just expect the answers to the universe to come from these incredibly complex, totally inaccessible places.
Because the expectation is always a high-tech revelation. We sort of assume the foundational truths of reality require equipment the size of a small city just to decipher the data.
Right. But today, we're unpacking a really rebellious critique of Albert Einstein's special relativity. And our starting point isn't a particle accelerator.
No, not at all.
It is actually a picture of a Gelato & Co. ice cream cone.
Which is, yeah, definitely a pivot from what you'd expect.
It really is. We are doing a deep dive into a massive, incredibly dense, and frankly, highly analytical series of writings by an author who goes by the name Xeonad 2023.
Yeah, and we are focusing on one specific post today.
Right, a post dated March 27, 2026. It's actually part 141 of this sweeping series the author cheekily titles Einstein Slacking.
Yeah, and the author is essentially arguing that for over a century, physicists have allowed abstract mathematics to, completely overlord physical, localized experience.
Which is a huge claim to make.
It is, and we're going to impartially walk you through exactly how this author builds that argument step by step. And, it starts with some deceptively simple geometry.
Okay, let's unpack this, because the author kicks off this whole critique by correcting a quirky geometric mistake they made in a previous post.
Right, the ice cream cone mistake.
Yeah, I was looking at the diagrams, and it basically starts with a simple 2D image of a circle,
Mm-hmm.
and the author had previously drawn an inverted triangle inside it, which represents the bottom of the ice cream cone.
Right.
And they placed the very bottom tip of that cone resting on the outer edge, like the circumference of the circle.
Yeah, but in this specific post, they issue a correction. They state that the pointy tip of the ice cream cone actually belongs perfectly in the dead center of the circle.
Wait, so just moving the point from the edge to the middle.
Exactly. And the moment you move that tip to the center, the whole mathematical model they are building shifts.
Oh, interesting.
Yeah. Instead of spanning the whole circle, the cone now looks more like a slice of pie. The wide part is at the top curve, and the point is right in the middle.
Right, okay, I can picture that.
And from there, the author draws these yellow arrows representing light rays. These light rays are traveling from the outside edge of the circle, the circumference, straight inward to the pointy tip of the cone at the center.
And then the author introduces a new element that complicates this. They draw a straight line that slices vertically through the right side of the circle.
Right, which in geometry, a straight line connecting 2 points on a curve is called a chord.
A chord, exactly. So we have light rays starting at the outer edge of the circle at the exact same time, and they're traveling inward toward the center at the exact same speed.
And because they all start at the edge simultaneously, and they're traveling the exact same distance to the center at the exact same speed, logic basically dictates they will all arrive at the center point at the exact same time.
Right, they have to.
However, as they travel inward, some of those rays have to cross that straight vertical line. They have to cross that chord.
Right, and because the chord is perfectly straight, but the outer edge they started from is curved, those light rays have to cover different distances to reach the chord.
Exactly, which means they will cross that straight line at entirely different times.
To make sure you, the listener, can really visualize this without, staring at a diagram, let's take it out of a 2D drawing for a second.
Good idea.
Imagine you are standing in the exact middle of a perfectly circular room. The walls are curved equally all around you. Now, let's say a bunch of camera flash bulbs are mounted on those circular walls, and they all go off at the exact same millisecond.
Well, since you are in the exact center, the light from all those flashes travels the exact same distance to reach you.
Right.
So the light hits your eyes all at once in a single, simultaneous burst.
But imagine there is a straight, flat glass wall slicing right through the middle of the room, like between you and some of the flashes.
Okay, so that glass wall is our straight chord.
Exactly. The light from the flashes will hit the middle of that glass wall first, because the middle of the flat wall is physically closer to the curved outer wall.
Yeah, that makes sense.
Then the light will hit the outer edges of the glass wall a split second later. So the light crosses the straight glass wall at completely different times, one after the other.
Right.
Yet when the light continues on and finally reaches you standing in the center, it hits you simultaneously.
And that realization, that is the cornerstone of the author's entire thesis.
Oh, really? Just that difference in timing.
Yeah. Simultaneous arrival does not mean simultaneous origin, and crossing an intermediate space at different times doesn't prevent simultaneous arrival.
All right, because you still get hit by all the light at once at the end.
Exactly. And that point in the center, you standing in the middle of the room receiving the light, is what the author defines as the camera eye.
The camera eye. It is the localized physical point of observation.
Yes. The camera eye is a physical object that acquires delayed information.
Right, because the light doesn't exist as a usable piece of data for the observer until it actually hits that camera eye.
Exactly. And this physical limitation brings us to the author's primary critique of modern physics. It's this massive tension between pure mathematics and physical reality.
Okay, how so?
Well, the author argues that mathematicians operate with what they call a God's eye view.
A God's eye view.
Yeah. In pure mathematics, you can define an x and y coordinate plane, right? As a mathematician, you can declare that at time 0t = 0, you magically know the exact state of every single point on that massive plane simultaneously.
So you are essentially hovering over the universe, just seeing the state of everything everywhere instantly.
Right. But the author says this is a mathematical fantasy.
Because in physical reality, information does not travel instantly.
Exactly. It is bound by the speed of light.
So if the physical world does not have a God's eye view, what does it actually look like in real life when we don't know everything instantly?
We are limited to the camera eye. We only know what has arrived at our specific location.
The author used a train analogy for this that, honestly, it took me a minute to wrap my head around, but it perfectly illustrates this gap between math and reality.
It's a really good analogy.
Yeah. Imagine your camera eye is located inside a building. You are looking out a window. And let's say a kilometer away from your window, out on the flat ground, there's a train track.
Yeah.
You are watching a train move along that track. In a mathematician's God's eye view, you would know exactly where that train is on the track at time 0. You just look at the coordinate grid.
But in physical reality, you are a kilometer away. You cannot know where the train is at t = 0 instantly.
Right.
You only know where the train was when the light rays bounced off the side of the train, traveled that kilometer through the air, and finally hit your camera eye.
So you are constantly experiencing a delayed version of reality based on when the light finally reaches your specific physical location.
Precisely.
Wait, but doesn't relativity account for the speed of light?
Isn't that the whole point? I mean, Einstein definitely thought about light.
What's fascinating here is it's a really common mix-up.
Okay.
The famous E = mc² equation is actually about the equivalence of mass and energy.
Right, right.
The part of Einstein's work the author is targeting here is his other major postulate in special relativity,
Which is?
that the speed of light is constant for all observers, regardless of how fast they are moving. And the author argues that Einstein's method for proving this relies entirely on a mathematical fantasy.
Okay, I see. Because the author's notes talk a lot about inertial frame A and inertial frame B.
Yes, and when Einstein talks about an inertial frame, he's basically just talking about an object like a spaceship or a train, moving at a steady, unchanging speed.
Right.
But the author says Einstein treats these spaceships purely as invisible math grids sliding past each other.
Exactly. Einstein sets up these inertial frames and calculates their relative velocities, but according to the author, he never anchors them to a physical information acquisition object.
He never anchors them to the camera eye.
Right. He calculates the relative difference between the mathematical grids, but completely ignores the localized camera eye that is actually waiting for the light rays to arrive.
So Einstein is doing the math from the God's eye view, hovering above the train tracks, instead of doing the math from the perspective of the physical eye, looking out the window a kilometer away.
Yes. By treating the inertial frames as abstract mathematical realities rather than as delayed optical experiences, the author claims Einstein stripped the physical observer out of the equation entirely.
Wow. Okay, so if Einstein's purely relative mathematical model is flawed because it ignores the physical delay of the camera eye, who does the author think got it closer to right?
Well, the author points back to a physicist whose work actually predates Einstein's special relativity, Hendrik Antoon Lorentz. Yeah. Lorentz was working heavily with the physical concepts established by James Clerk Maxwell and the electromagnetic field.
Let's pause and explain that, because the electromagnetic field is a huge shift from abstract math grids.
Hmm.
Lorentz viewed the electromagnetic field as a physical medium.
Think of it as a vast universal ocean of space that light actually travels through.
Okay, an ocean.
It's a global space. And if an observer, our camera eye, moves physically through this global electromagnetic ocean, interesting things happen to the light reaching them.
Let's say our camera eye is moving through this field at 60% the speed of light, which is 0.6 c.
Right.
Because the camera eye is physically moving through the space where the light is traveling, the light coming at the camera eye from different directions will have different apparent speeds.
It's just like running in the rain.
No, I like that.
If you run forward, the raindrops hitting your face seem to be hitting you faster and harder. But if you run away from the wind, the rain hitting your back feels slower.
Right, even though the rain is falling at the same speed.
Exactly. To the moving observer, the apparent speed of light in the X, Y, and Z directions changes based on their movement through that global field.
The author used an analogy of a transparent sphere to explain this, which I really want to simplify so it's easier to visualize.
Go for it.
Imagine you are sitting inside a perfectly spherical, transparent glass bubble car.
Okay, a bubble car.
And you are driving this glass bubble car over a massive, flat, glowing floor that is shooting light straight up.
Got it.
If your glass bubble is sitting perfectly still, the light rays from the floor come straight up and hit the bottom of your bubble at perfect 90-degree right angles.
Right, because you aren't moving.
But the moment you start driving that glass bubble car forward, you're moving through the space where the light is traveling.
Yes.
So the light rays shooting up from the floor no longer hit the bottom of your moving bubble at perfect right angles.
Because your forward motion changes the angle at which the light enters the glass.
Exactly. And it changes the apparent speed of the light as it finally hits you sitting in the center. Your movement through the physical field changes how the delayed light arrives at your localized camera eye.
And here's the thing. The author claims that Lorentz almost had this perfectly right.
He understood the rain analogy.
Yes, he understood these apparent speeds of light. But then Lorentz looked at a very famous physics experiment and, according to the author, made a fatal mistake that sent all of modern physics down the wrong path.
Here's where it gets really interesting, because this is the turning point of the author's entire argument.
It is. They're referring to the Michelson-Morley interferometer experiment.
Let's do a quick breakdown of what that experiment actually was, because it's crucial for you to understand this.
Yeah, definitely.
In the late 1800s, scientists believed that if the universe was filled with this ocean of an electromagnetic field, which they often called the ether back then, the Earth must be sailing through it as it orbits the sun.
Right. So there should be an ether wind.
Exactly, a wind of
Yeah.
light, basically.
So Michelson and Morley built a device to race two beams of light against each other. They split a single light beam and sent the two halves racing at perfectly perpendicular angles.
Okay.
One bouncing back and forth in the direction of the Earth's movement, and the other bouncing perpendicular to it. The idea was that the wind of the universe would slow one of the beams down, causing them to arrive back at the detector at slightly different times.
But they found absolutely nothing.
Nothing at all.
No matter which way they pointed the machine, the light beams always finished the race at the exact same time. The speed of light appeared perfectly constant.
Which left scientists completely baffled.
So how did Lorentz try to explain this?
Well, Lorentz calculated the apparent speeds of light based on movement, just like our glass bubble car. But, just like the mathematicians the author criticized earlier, Lorentz took those localized apparent speeds and applied them to a global mathematical map.
Oh, he zoomed out to the God's eye view.
Exactly. He forgot to tie them strictly to the local camera eye, receiving the delayed information inside the bubble.
Interesting.
Because of this mathematical mix-up, Lorentz looked at the math and concluded that to make the equations work, the objects themselves must be physically shrinking in the direction of their motion.
And this became known as Lorentz contraction.
Yes.
He mathematically concluded that if an object moves through the electromagnetic field, it literally physically compresses.
And the author strongly objects to this.
Yeah, I was reading the author's notes on what they call the helium atom argument, and honestly, it's a fantastic reality check.
It really is. The author basically asks us to apply basic common sense to this math.
Right.
Let's say a helium atom is just sitting at rest in the electromagnetic field. Now, an observer flies past that helium atom at near the speed of light. Does the helium atom suddenly physically squish? Do its protons, neutrons, and electrons literally compress into a pancake just because someone else is flying past it really fast?
The author says absolutely not. The idea that matter physically shrinks based on relative velocity is an illusion.
Right. Does the observer's speed physically alter the atomic structure of an object completely independent of them?
No. The author claims this shrinking is an illusion born of mathematical abstraction. It completely ignores the real-world, localized delay of information.
But if it's just an illusion caused by delayed light, we have to ask why mathematicians and physicists went to such incredible lengths to mathematically prove that the space was shrinking.
Why build this elaborate system at all?
Exactly.
Well, the author uses a fantastic analogy to explain exactly how the mathematicians accidentally created this grand illusion. It's the Wimbledon center court umpire analogy.
I love this one.
Imagine a tennis match at Wimbledon. You have player 1 on one side of the net and player 2 on the other side. And you have the umpire sitting high up in the chair at the center of the court.
And the umpire in this scenario represents our localized camera eye.
Exactly. In physical reality, those players are running all over the court. Sometimes player 1 is closer to the umpire, sometimes player 2 is closer.
Right. And because light takes time to travel, the delayed light from their movements takes different amounts of time to reach the umpire based on where they physically stand.
But mathematicians want the speed of light to be a perfectly standardized constant from all angles no matter what.
They hate the messy delay.
Yeah. They want the umpire to receive the visual information of the tennis ball at the exact same constant speed,
Right.
regardless of where the players are.
So how do they force that to happen in the math when player 1 is physically much further away than player 2?
They have to cheat the math.
Right. If the speed of light must be constant in the equation, but the distance is physically greater, the only way the equation survives is if you mathematically shrink the distance.
So they literally shrink the court on paper.
Yes. The mathematicians essentially twist the coordinate space. They use complex angles to force player 1 and player 2 to seem perfectly equidistant from the umpire at all times in the mathematical model.
So by forcing the players to be equidistant in the math, just to keep the speed of light universally constant, they artificially create the illusion that the physical space itself, the tennis court, is shrinking or expanding depending on how the players move.
Exactly. They forced a mathematical purity onto a messy, delayed physical reality.
Wow.
If we connect this to the bigger picture, that mathematical cheat is Lorentz contraction.
Right.
Modern physics, starting with Lorentz's mix-up and cemented by Einstein's special relativity, took a measurement illusion. An illusion caused simply by the fact that light takes time to reach our camera eye, and mathematically mistook it for a literal physical transformation of matter.
We actually think trains are physically shrinking as they speed by, when really, the light from the front of the train and the back of the train are just hitting us at different times.
Exactly. We traded the messy physical reality of the observer for the clean, instant fantasy of the God's eye view.
We prioritized a mathematical coordinate system over the physical reality of a localized lens receiving delayed photons.
And the author is using the basic geometry of a circle and a chord to prove that crossing space at different times doesn't prevent simultaneous arrival.
We started with that ice cream cone.
Right. From there, they dismantle the foundational assumptions of inertial frames. They advocate for a complete return to physical, localized reality.
A physics grounded firmly in the physical camera eye rather than, floating in an abstract mathematical void.
Yes.
So what does this all mean? Well, it is crucial to remember that this is just one thinker's highly rebellious perspective.
Oh, absolutely.
They are taking aim at over a century of fiercely established, rigorously tested physics. We aren't saying you should throw out your physics textbooks today based on a blog post.
No, definitely don't do that.
But the author's work serves as a brilliant, provocative reminder to always question the foundational assumptions of any field. Sometimes you have to trace the complex math all the way back to the physical reality it claims to represent.
And before we wrap up, there is one final, lingering implication of the author's work to mull over on your own.
Oh.
It builds directly on this obsession with the localized camera eye. If the author is right, if our entire fundamental understanding of reality is purely dependent on the localized delayed arrival of light rays hitting our own specific physical camera eye,
Right.
does that mean a shared objective present moment across the universe is scientifically impossible.
Wow.
Yeah.
Because if reality is only constructed at the exact point of impact on the lens, and every lens is in a slightly different physical location.
Exactly. Every single lens in the universe is receiving light from a slightly different angle and with a slightly different delay.
Yeah.
Are you, the listener, fundamentally trapped in your own unique, slightly delayed version of the universe? A universe that literally no one else can perfectly share.
You are basically sitting in the center of your own circular room. The flashes of the universe are hitting you in a sequence completely unique to your exact coordinates. You are your own camera eye.